All right, so I'm going to take you through a few questions for chapter 4.3. This is dividing polynomials. So we're going to start with long division. Okay, it takes a little bit of work, and I'm going to show you synthetic eventually, but this is going to be the first method I'll show you. All right, so if we have something like this, we're dividing by a monomial. So this term down there, that's just a monomial. So the best way to do this is similar to things we've done before. So remember, if you have something like 3x plus 6 divided by 2. If you want to simplify that, we split both of these with the 2 on the bottom, and this would be 3 over 2x plus 3. The question above is going to work exactly the same way. So we're going to take the 5ab and split it over each one of those. So 5a squared b over 5ab minus 15ab cubed over 5ab plus 10 a to the third b to the fourth over 5ab. And then what you need to do from here is you actually just need to simplify it out. So simplify this fraction, simplify this fraction, simplify this one. Okay? So this one will be, so the 5s are going to go away. Take one of the a's out. We have just an a left, and the b's cancel. All right, so there's just an a left for that first one. For the second fraction, 15 and 5, that'll cancel out to a 3 on top. So 3, the a's will go away. We're going to take out one of the b's, so we'll have 3b squared. And then here, the 10 and the 5, that'll cancel out to a 2. That's just simple division there. And then a to the third, we got to take out one of those a's, so it'd be 2. A squared, b to the third. We're just using subtraction of exponents with these because this is a to the first down here. 3 minus 1 is a 2. Okay? And so that's how you do that when you're dividing by a monomial. Okay? You don't have to necessarily write that step out here, but you have to think about it to get your answer. So we could have just looked back at the top question and said, okay, what's left after I take out 5ab? That's just the a. What's left after I take out the 5ab from there? That's our 3b squared. What's left after I take out the 5ab from there? That's 2a squared b cubed. Okay? Let's look at another one. So similar here. I'm going to do this where I don't do that middle step. Okay? So we're going to take 3x squared y, this one, out of each of these terms above. So if you want to try it first before you see the answer, pause the video. Otherwise, we'll just keep going. So taking the 3x squared y out of here. And now this one's a little bit tricky because everything cancels. If you have a 2 over 2, they technically cancel, and what are we left with? A 1. So if I got 3x squared y over 3x squared y, that's going to cancel to just a 1. All right? And then the next term, I got to divide it out. So 6 divided by 3 is 2. We're going to have x to the third left because we take away those exponents. And we're just going to have a single y left. And then the third term, when we do that one, we're going to have a 3 left, x to the fifth, and y squared. So that's what's left when we divide by this monomial. Okay? So those are the simpler versions of division. That's not long division yet. That's just simplifying. Okay? So let's look at long division from what you learned a long time ago, because this is very similar to what we're going to do with polynomials. Okay? So long division, back in the day, you looked at, so we're doing 125 divided by 7. And we'll just go to a couple decimal places. So you look at the first number, and you ask yourself, does 7 go into that? No, it doesn't. So you either put like an x up there for a placeholder, or maybe you put a 0 up there, or maybe you just didn't write anything at all, and you went to the next number. So now we have a 12, all right? So 7 goes into 12 one time, okay? And then you're like, okay, well, 1 times 7, right? 1 times 7 is a 7. We write that down there. And remember what you do with that number when you write it down there. You got to subtract it. So 12 minus 7 is a 5. And 7 does not go into 5, so that's when you drop the next one down and you do the same process. Okay? So you ask yourself, how many times does 7 go into 55? Well, we know it's 7 times, okay? And you're like, 7 times 7 is 49. And we subtract that. And we have 6 left over, okay? And then, again, 7 doesn't go into 6, so we did that one right. And you had a few different options here. You learned different things in different levels of math. When you first started out, you were like, okay, 6 is my remainder. So you did 17 remainder 6. That's a way to do it. If we go to the next level, we started doing fractions. So we said 17 and 6/7 we had left over. That's the way we're going to do it today. And just a reminder for one more way that you did it, you put a decimal place here and here, and then you put a 0 there, and then you drop the 0 down, and you kept going with it. Okay, and I'll just remind you of that here real quick. So 7 goes into 60. That's 8 times. We have a 56 because 8 times 7 is 56. That's 4 when I subtract those over. And then you bring down another 0, okay? So decimals, like the 125, we could just do a ton of zeros here and just keep dividing. So you could keep dividing this out to see how far you got. Maybe this wouldn't even stop. Well, or maybe it would, but you would have to keep going, okay? So that's how you do it. The way I want you to think of it is this. We want 17 and 6/7 would be left over, okay? So the process to take away here is how many times does 7 go into the number, all right? So off to the side, you're kind of doing that. So, okay, 7 goes into 12 one time. We wrote the 1 up here, and here's the big thing we got to remember. So 1 times 7, that's how we get that number down there, and you always have to subtract it. So I'm going to try to use polynomial divisions exactly the same way as what we did with that long division question. Okay, so this is the first long division of polynomial that we're doing. So we have this polynomial, so a 4th degree polynomial divided by a 2nd degree polynomial. We'll just do a couple of these, and then you can practice these on your own. So we set it up just like our long division problems on the last page, except these have a lot of x's with it, okay? And then another reminder with these is when you look at your polynomial here, you want to have it in descending order, and you want to make sure you have every term listed. So this is the x to the 4th, this is x to the 3rd, and then we just jump to an x. So we're missing an x squared term. So you want to put a placeholder for the x squared term, and I'll show you what that looks like here. So right here, we don't have an x squared, so we're just going to write a 0x squared, okay? Because you could technically put a 0 in anything, and it doesn't really change the question. All right, and now we have it set up, ready to roll. So what you want to pay attention to on these is just the first term of each one of these. We want to pay attention to the 3x to the 4th and the x squared. All right, so we look at how many times this goes into this. Well, it might be hard to think about it that way. So the easier way is you just divide the two and then see what you got left. So if I divide 3x to the 4th over x squared, I got 3x squared. That's your first number that you're going to use up top, or your first term. Okay, again, so it's starting this out. You divide this term by this term, which is 3x squared. That goes up top, all right? So remember what you did with that number that was up top. Now we take the 3x squared, and we have to multiply it into each of these to figure out what goes here to subtract. All right, so 3x squared times x squared is 3x to the 4th, which is what we want because we want those to cancel out, minus 9x to the 3rd, plus 15x squared. Okay, now you got to remember what you did with these numbers. All right, so thinking back here, we subtracted those when we wrote them there. So the same thing applies here. We're going to subtract those numbers, but this is a whole polynomial here. So if you subtract the whole thing, every sign needs to change, okay? So this would be a minus, this would be a plus, this would be a minus. And then you're ready to go, right? So these should cancel out. That's the point of division. We're simplifying this out by division. And then we may have things left for the rest of these. So we have a negative 5x cubed and a positive 9x cubed. So that's a positive 4x cubed. And then minus 15x squared. And now we only have two things here. We have three things here. That means we need to drop down the next term. And we're doing it again. Okay? So if you understand that first round there, you're just doing the same thing all the way to the end. It's just long division, right? Exactly what we did on the last one, but with variables and polynomials, okay? So we're looking here. What is 4x to the third divided by x squared? That would just be a 4x, right? So that's the number that goes up top, positive 4x. And now you're going to take that positive 4x and multiply it through everything to figure out what goes here. Okay, so let's do that. We'll write it below. So 4x times x squared is 4x to the third. And then minus 12x squared plus 20x. Okay, then you need to remember, since we wrote these down here, we're subtracting everything. So flip our signs. And then see what we have left over. So those go away, as they should. Negative 15, positive 12 is a negative 3x squared. And then 4x and a negative 20 is a negative 16x. And we drop down to 6 because we need three things down there. Okay, almost done here. So same process, right? We're down here. We divide 3x squared, or negative 3x squared, by x squared. See what we have left. So x squared, they're going to go away. We just have a negative 3. So negative 3 goes up top. And then we're distributing through again. Okay? So negative 3 would be a negative 3x squared. We'll change that to red. All right, negative 3x squared plus 9x minus 15. And then don't forget, so this is the place where everybody makes mistakes. I've been intentional about using different colors of ink and saying it, but this is the place where everybody makes mistakes. So if you're looking at this, those don't cancel. Those would give me a negative 6. So we want them to cancel, so we got to flip those signs. Okay? So then these are out. We have a negative 25x, and then a positive 9. And then you have nothing left to bring down here. So we're not going to stick a 0 on the back end and keep bringing stuff down. This is the remainder. Okay, so in polynomials, or polynomial division, when you have nothing else to bring down, you're done, and you need to write your remainder. So remember how we wrote our remainder here on the last one, like this, a fraction, 6 over 7. So that was, let me get rid of some of this stuff to remind you. We were left with the 6 there. Okay? So we wrote this over this. So back here, we're going to have to write this remainder over this divisor with this polynomial in the front. All right? So it looks ugly. The concept isn't too bad. So 3x squared plus 4x minus 3. That's what we got up top. And now we got to write our remainder. So you always add the remainder. That's the best way to not make a mistake. So plus a negative 25x plus 9 over divisor. X squared minus 3x plus 5. And that is your final answer for long division of polynomials. Is it a long process? Yes, it's called long division, okay? With polynomials that are a degree 2 or larger, in my class, you have to use long division. There are ways to do it with synthetic division, which you could look up, and you could try that, but we're not going to go through it in class, okay? So Let's try one more of these, and then we'll see if we can do some practice. Okay, so we have this polynomial divided by this polynomial. So it's a 4-term polynomial divided by a binomial. So x minus 2 is on the outside. And then we have x to the third plus 5x squared minus 7x plus 2. So begin the process. We look at the front two terms. So x to the third divided by x, that tells me what my first term up top is, which is x squared. Now we've got to multiply x squared through both of these. We'll have x to the third minus 2x squared. And remember what we have to do with these. Switch the signs because we want to subtract. So those are gone. We got a 7x squared. And there's only one thing down here, so we have to bring down the next thing. Because we should have two things, because there's two things here. And then we're looking down here now. So 7x squared divided by x is a 7x. So that's the next term up top. So plus 7x. And now we take the 7x through there. Okay? So we'll have 7x squared minus 14x. And remember, change the signs. Those go away. We got a 7x again left here. Bring down the 2, and you're almost done. So you kind of see this process is the same all the way down. If we understand the first round of it, we should be able to do the rest of it. So we're back looking here. 7x divided by x. We're trying to figure out what number goes up top. It's just a 7. So put our 7 up top. Take it through here, distribute it. And we got 7x minus 14 down here. Don't forget to change the signs. 7x's go away. We got a 16 left over. So 16 is the remainder, and remember how we wrote it. And we have this stuff up here. And then our remainder, which is 16, goes over the x minus 2. And you have completed your polynomial division. Okay? So we covered dividing by a monomial, and we covered polynomial long division. So hopefully this helps you understand the lesson. Please email me if you have any questions. Thank you for watching.